Alright, let's take a look at compound interest and the number e. So, first thing we want to do is use a calculator and take this calculation in for 10 to the first and then to the second and to the third. So in your calculator you want it to look like this, okay? And then you can obviously round if you want. So 10 to the second would be 2.705, okay? And then we do it for the other ones. So we type it into your calculator and you get for 10 to the third about 2.717, 10 to the fourth about 2.718. Then we do it for 10 to the fifth. So we type it into our calculators. Just like this, right? We get 2.718. This was 182. Okay, and then to the sixth, hopefully you can kind of see a pattern here. And we get 2.7183 again. And that's from rounding, so they were slightly different. Okay, so what this is doing is it's getting us this number e, kind of like how pi is a number. E also is in the calculator, and you end up with about 2.718. Okay, is about the number it's approaching, and that equals e. Okay, and it has to do with this this idea of interest. Compound interest is where we use it a lot, but that's where it's used. Alright, so we treat e just like we do any other number. So e squared times e to the fourth would be e to the sixth. E to the negative 3 times e to the fifth would be e to the 5 minus 3, or e squared. We'd get 3 squared is 9, e to the 8x. This one we'd get 1/4 to the third, okay, which would be 1/64 e to the negative 6, which then that would put it down at the bottom, so it would be e to the 6th. For 7, we'd get 4 e to the, then we add those, x plus 2x plus 1, would give us 3x plus 1. Number 8, that I'm assuming is a cube root. Yeah, I double checked on a better copy, a larger one, and that is. So the cube root, right, would give us, that's like 64 e to the 9x over 1/3, which that'd be 64 to the 1/3, which, since 4, where is it? 4 cubed is 64, 64 to the 1/3 would be 4, e to the 9x over 3, which would be e to the 3x. Okay? Now, if we're using a calculator to do it, like on 9 and 10, we just, on a calculator, they should have that function e, so I just type it in, e to the third, and that gives me about 20.0855. Okay, 2 times e to the 1/2 gives us about 3.29744, and 11 negative 1.2 e to the 5th gives us negative 178.096. Alright, okay, now looking at exponential growth or decay. Remember, when we're dealing with exponential growth, if the number you're multiplying by, okay, the number that's the base, if that is a number that is greater than 0, well, greater than 1, I should say, basically not a fraction, it's going to be growth. Okay, so this one with that negative would be like 5 over e to the 3x. Okay, so that would be a fraction. So being that the e's on the bottom, that would be like 5 times 1 over e to the 3x, so that would be decay. Okay, once again, that negative exponent would make it decay. The positive exponent, even though it has a fraction in front, that would be growth. And you could use Desmos to graph them to double check. Remember, growth looks like this, decay looks like this. Alright, then if we're to graph each function, so we've got e to the negative x. Okay, so we could make a table of values. Honestly, I'd say the easiest thing we can probably do is just to graph these on Desmos. So I'll do that and put up a screenshot for you. So we look at it and it would look something like this. Okay, so once again, that negative x makes this decay, goes down, asymptote here. Okay, this one, that plus 2 bumps the asymptote up there, and that 3 and that 2, and that 3 plus the wrong 2, that 2, bump it up to a y-intercept of 5. But they would look something like that for those graphs. Alright, so let's take a look now at this. Okay, so now this is where we use a lot. Notice this right here. Okay, that's kind of that same thing that we derive e from, that same. So it's naturally that we use it. So we've got this formula. Okay, A is the amount you want to get, P is the principal, R is the interest rate as a decimal, N number of times per year it's compounded, and T is time. Then if it's compounded continuously, that's where we use the E. Okay, so that would be P, R, and T would be the same. We don't need N because that E takes the place of N essentially. So 17. So basically we're just going to write the formula, plug it in to a calculator, and do a lot of that. We just got to make sure we know what we're going after. So a coin had a value of $1.17 in 1995. Its value has been increasing at 9% per year. What is the value after 5 years? Okay, so let's see what we've got. So P would be 117. Okay, 9%, that would be our R, 0.09, right? Okay, per year means it's compounded yearly, so that would be 1, so N would equal 1, and then time would be 5. So we plug it in, so A equals 1.17 times 1 plus 0.09 over 1 times 1 times 5. And then I would just type that into my calculator to get an answer here. So 1.17 times 1 plus 0.09 over 1 to the 1 times 5. And we end up with 1.8, and since we're dealing with money, we would just round to that. So it's at $1.80 now, which doesn't seem like a lot of money, but for it just sitting there, 5 years isn't a lot of time either. Okay, 18. Gina deposited $1,500 in an account that pays 4% interest compounded quarterly. Okay, so that's 4 times a year. What will the balance be in 2 years? So set it up. Our principal right here, 1,500 times 1 plus interest, 0.04, because we turn it into a decimal, compounded quarterly, and 4 for the N times the time 2. Okay, so we type that into our calculator. We end up with 1,624.29, which is not bad. Made about 125 bucks. Okay, 19. The Garcias have $12,000 in a savings account. The bank pays 3.5 interest on a savings, compounded monthly. So P would be 12,000. R would be 0.035. N would be, well, there's 12 months in a year, so 12. And then T would be 3. So A equals 12,000 times 1 plus 0.035 over 12 to the 3 times 12. So we type that one into our calculator. And we end up with 13,326.50. So in 3 years, they were able to make about $1,000, well, about $1,000, 300. Okay, 20. Determine the amount of interest earned on a 25. So P is 2,500. It was invested. Its rate is 0.0525. Annual interest compounded monthly for 4 years. So N is monthly would be 12. T is 4. But now you just want the interest earned. So we don't want the total amount. Okay. So we would just put in our numbers. The difference is, and we're just going to find the difference between 2,500 minus, or that total amount minus 2,500. Okay, so I type this into my calculator. So we type that in and we get 3,082.78. Subtract the 2,500 from that, and we end up having 582.78. That's what it wanted. It wanted just that interest, that extra. All right. Okay, 21. So we deposit 975. We've got our interest, so principal 975. Our interest 0.055. Compounded continuously, so that would be the E, and the time would be 6. So we look at this formula now. P times E to the RT. So A equals P 975 times E to the rate 0.055 times 6. Type that in your calculator using the variable E, and we get our answer. So 975 times E to the 0.055 times 6. We end up with 1356.19. Okay, not too bad for 6 years. Okay, 22. What is the final amount if you invest 5,000 for 30 years at 4.2 interest compounded continuously? So 5,000 times E to the 0.042 times 30. Okay, so this is over a large amount of time, isn't it? And we end up with 17,627. So after 30 years, you'll triple your money for just sitting in the bank, which not too shabby, is it? Okay, 23. You invest 3,300 in an account that compounds continuously. What will you have at the end of 6 years with this interest rate? So very similar to 21, isn't it? So A would equal 3,300. Then times E to the 0.055 times 6. Okay, we type that into our calculator. Oops, too many threes. And we end up with 4,590.19. Okay, now 24 says, how long would it take for you to earn 10,000 off of an investment of 2,500 with an 8% rate if compounded continuously? So let's think about what we're trying to get here. Okay, trying to see our amount, right? Our amount we want is 10,000. Our principal 2,500. Okay, compounded continuously, so that's E, times our rate, 0.08, but we're trying to figure out the time, aren't we? So 0.08 times t. Okay. All right, so now we try to figure out how can we get that. Well, we could try to just guess and check, couldn't we? However, there's a better way. In light of what we've just been learning, we know the difference or the reciprocal to figure one out or another. Okay? So the reciprocal of exponentials are logs, right? So what we need to do is we need to set it up so we just have this log. So first thing we do is divide by 2500. That would give us 4 equals e to the 0.08 times t. Okay, now remember it's usually log and then the base, so log base e, which if you recall, log base e we actually write ln for natural log. So I'll change it after this. So log base e of our output is going to be equal to the exponent. Okay, so I'd write natural log of 4 equals 0.08 t. So then to get t by itself, we divide by 0.08. So we go the natural log, which you can find on your calculator, of 4. And we take that and divide it by 0.08, and we would end up with 17.3287. So basically a little over 17, about 17 and a half years is how long it would take for us to go from this, to essentially quadruple our money. Okay. All right. So let's keep going. How long would it take for you to earn $1 million off an investment of $10,000? Okay, so now we're doing the same exact thing, right? This would equal this e to the 0.045 times t, because we're looking at long. Start off by doing that, so cancels, 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 cancels. So basically 100 would equal e to the 0.045 times t. That becomes a natural log of 100 would equal 0.045 times t, divided by 0.045, and that'll get us our time. So once again, natural log of 100 divided by 0.045, and it would take 102.337 years. So a little over 102 years, okay? So that would take some time, wouldn't it? Okay, 26. How long would it take you to earn $1 million off? Oh, 25 and 26. Oh, crap, we did 26. Because 25, we'd have to use a different formula. So let's do that. I didn't even notice that. Compounded every month, we'd then go $1 million equals 10,000 times 1 plus 0.045 over compounded every month would be 12 over 12 times time. So we started off the same way. So we divide, right, by that. That gave us 100 would equal 1 plus 0.045 over 12 to the 12t. Okay. Now we could simplify this, couldn't we? So that would give us, because we could type that in a calculator, because those are all numbers. So 1 plus 0.045 over 12. So that's 1.00375, 12t equals 100. So that would be the log of that base, which would equal, of 100, would equal 12t, so then we divide it by 12. Okay, so I go log base of 1.00375 of 100. Okay, I'm going to take that and divide it by 12. and we end up with about 102.529. So, slightly quicker to go with this bottom one. Alright, 27. What rate would you need in order to earn $5,000 in interest with an initial investment of $250 after 10 years? So, okay, so this just wants the $5,000 in interest. Rate of $250 times, let's see, that's where the issue is going to be, right? So if we're looking for just an interest, it's the principal times the rate times the time. Okay, so if we want 5,000, it would equal 250 times the rate times 10. Okay, we're not having to, because of the compounding and that, we're not having to do that. So 250 times 10 give us 2,500, so we divide by 2,500. Okay, we should get what, 2? Okay, which would equal our rate. So that means we'd have to have, turn it into a percent, we'd have to have a 200% interest rate. And without knowing how it wants to be compounded, that's as much as we can do. So for 28, same idea. We want to earn 2,000 in from an initial investment of 500 after 15 years. So 500 times 15 would give us, we divide by 7,500. Okay, 2,000 divided by 7,500 would give us 0.2666667. So basically 27% interest rate, if we round up and go from there. Okay, 29. If you were to want 15,000 in 10 years with a 5% interest rate, what principal would you need to invest to make that happen? Okay, so for this one, we want 15,000. Okay, we want to know the principal. We're just going to assume it's compounded continuously times 0.05 times 10. Okay, so for this one, we want to figure out what P is, so we divide by, what's 0.05 times 10? Should be 0.5? Yeah, so e to the 0.5, we would divide by that. That would cancel, leaving us with P equals whatever 15,000 divided by e to the 0.5 is, which would be 9,097.96 cents. That's how much you would have to invest in 10 years to make 15,000 at that rate. Okay, so last one. If you were to want 1 million in 30 years with a 3.5 interest rate, what principal would you need to invest to make that happen? So here's our end result. Okay, we want to know the principal times e to the 0.035 times 30. So 0.035 times 30 is 1.05. So we divide by e to the 1.05. And that'll get us our principal. We end up with $349,938, which if you had that much that you could invest at a 3.5 interest rate for 30 years, you'd come home with $1 million, which wouldn't be too bad for doing nothing other than just leaving the money alone. However, I think for most of us it would be tough to leave that amount of money alone. All right, there we go.